Okay.
Okay, here we have the DC motor we're going to be using as a prime mover. Then we have a synchronous machine, a synchronous motor that actually we're going to be using as a AC alternator for this lab. Now over on the other side, we have another set with a DC motor and a synchronous alternator over there. Okay, now here we have our controls, so walk you quickly through this. This is our DC motor starter. Okay, that's going to be our prime mover, and we're going to control the field here to control the speed of that motor, and that's going to, well, if we're adjusting the speed of our prime mover with a generator, what does that do? Adjusts our frequency. Okay, so that's how we're going to control our frequency. Now also, we don't know if our alternators are in phase with each other, if the phase orders are the same, A, B, C, C, B, A. So we're going to be using our lights here to tell us that. So that's how that's going to work is we're going to see all the lights are going to flash on and off at the same rate. If the phase orders are the same, they're going to alternate randomly if the phase orders are not the same. Okay, then also we got to see how far at a step they're going to be. We have our synchroscope here. This is going to tell us how far when we have A phase on one and A phase on the other, when they're overlapped. Our synchroscope here is going to be at 0. So when we have our A phases on both, A, B, and C, all three phases for both alternators, when they're perfectly overlapping each other, our synchroscope here will be at that line at the top. Also, if our phase order is correct, all three of these lights will be out. This is our 3 dark method. Okay? Also, while we're at it, we got to make sure before we parallel these guys, we have to have our voltmeters have to have the same output voltage from our AC output voltage here. It has to be the same for both. So what things do we have to make sure are the same before we parallel the generators? Well, voltage has to be the same, frequency has to be the same, voltage has to be the same, frequency if they're at a step, and the phase order. They both have to have the same phase order. Okay guys, now here I'm going to start off one of the generators. So I'm going to use the DC motor starter here. I'm going to slowly bring our motor up to speed. I'm going to adjust the speed of that motor by adjusting the field rheostat here. That's how I'm going to set our frequency. So I'm going to initially start it up. I'm going to try and get the frequency up to 60 Hertz. Then I'll go over to the other one and I'll try to get that one up to 60 Hertz. And then I'm going to start trying to match the 4 different settings that we have to get the same. So here we go. Okay, motor's up to speed. Our frequency is pretty well at 60 Hertz right now. Now I'm going to go over, we're going to start the other one. When we do bridge these together, we're closing this breaker here is going to tie both supplies of the alternator together when we get to that step. So here we go, number 2. Okay, you know the lights are flashing now. When the lights are on, we're measuring the potential differences between the phase on one side of the lamp and the different phase on the other side of the lamp. Okay, they're flashing at random intervals. They're not all going on and off at the same time. That tells me right away our phase order is out. Our out of step relay is going crazy too, so that's going to be out. We have to adjust that. Our frequency is not the same, and our voltages. Our voltage there is about 240. Voltages are pretty close. So I'm going to stop both motors. Then I'm going to do a phase swap 2 phases on one of them around. Then we're going to turn it back on again. Okay. Takes a few minutes for it to decelerate. Now, because I don't want to open up the motor and swap the lines around at the alternator, I'm just going to do it here. Okay, they both stopped. Now we're just going to switch these two around, put it in like so. Okay, now we're going to go through the same process, starting these up. So I'm going to start the DC motor starter here, slowly put resistance, limit that inrush current. Starter's going to keep itself closed. Frequency went up a little bit. Set the frequency back to 60 hertz. We'll start off our next one. Now you can see our synchronizing module, the lights there, they're flashing both on and off at the same rate. Our phase order is the same for both alternators. Now, the rate in which it's flashing is proportional to how far out the frequencies are for the two. So right now, the frequency for this alternator is at 60 hertz. The frequency for this guy over here, well, it's around 63 hertz. So I'm going to adjust the speed of our DC motor here to make the motor go slower so we can reduce our frequency. Remember, frequency is proportional to the speed. And then you're going to notice when this goes down, our rate of flashing of our lamps is going to drop. Also, our out of step meter here is going to slow down. There we go. Now it's going to hunt back and forth a little bit. You notice the lights are all out. We're in step, in phase, frequency is the same. Voltage on this one is 210. Voltage on this guy is a little high. I'll raise this voltage over here.
Oh, that's cool.
Still falling out of step.
Now you adjust more.
It looks okay.
Yep, but you gotta wait till they're in.
I'm going to slow this down. We're still a little out of step. Okay.
Breaker.
So I can alter the speed of either to bring it in. Frequency is pretty good still. Now our synchronoscope and in. So once we got right near that that line, we snap this in, synchronize both or parallel both generators together, then they'll lock in and they'll follow each other. They will stay synchronized and parallel until one of them gets seriously out of balance with load or the other, and that can blow it out. But anyway, thank you very much.